Thanks for putting this paper on the program. I'm going to present created and the sum of its parts, aggregate versus aggregated inflation expectations. And this is joint work with Knotek from the Cleveland Fed, as well as Kristian Myrseth, Raphael Schoenle, and Michael Weber. And as always, the usual disclaimer for the Federal Reserve applies here. So what do we do in this paper? We do something very basic. We are concerned with the measurement of inflation expectations. And by measuring inflation expectations, we create a novel data set of micro and macro inflation expectations. By micro inflation expectations, I mean household inflation expectations for different PCE categories. That is, for example, households' expectation for food prices or the price of a new car. And by macro inflation expectations, I mean the conventional measure of household inflation expectations for aggregate headline inflation. And once we have created this data set, we will then secondly compare those micro inflation expectations to the macro inflation expectations and test for consistency as well as which measure of inflation expectations, either the canonical measure or our new micro-based measure, explains consumption spending plans of households better. And we obtain three main findings. First, we find that macro-inflation expectations exceed micro-inflation expectations and are much more volatile. That is, our new novel measure of micro-based category-specific expectations is less volatile over time than the traditional measure. Second, the internal aggregation mechanism of households from the category-specific inflation expectations to the aggregate headline expectation is related to salience of price changes, but also social demographic characteristics and to measures of task complexity for the aggregation. And lastly, we find that this novel micro expectation-based measure contains additional information about the consumption plans that is able to predict them better than the traditional macro expectation. So why should we care about this? First, our results have implications for the measurement of expectations. They suggest that we should rather focus on those micro expectations when we elicit inflation expectations of households as central banks than to use the conventional macro measure. The idea for this is motivated by the psychological literature that states that when households have to think about a very abstract, uncertain variable, for example, future inflation, this is a very difficult and complex task, so they might refer to the use of heuristics, and the measure might be biased in the end. So in this project, we take this very abstract concept of inflation for households and break it down into a number of more tangible, better understood variables, that is, consumption categories. And we then ask households about those categories because we suspect that they are less prone to the use of heuristics if the households understand better what we actually ask them about. Our results have important implications for the rationality of inflation expectations. There's a very influential paper by Comion and Gortnichenko where they reject the full information and rational expectations hypothesis by comparing inflation expectations to later inflation realizations, and they find that forecast errors are autocorrelated. We take a different view on rationality here by comparing the micro expectations to the macro expectations, and here we find an internal inconsistency. So we can reject the rationality of households from the internal side. And lastly, this has also policy implications. We find that the micro-based measures of expectations are less volatile, which might suggest that disaggregated inflation expectations that households actually use to build their spending plans are probably more anchored than we think from the conventional measure. And second, we find that inflation expectations and spending plans of households are best explained by their energy and food inflation forecasts, that is by the non-core components of headline inflation, which might have important implications for central bank communication, but also for the focus on the core inflation target if households excessively focus on energy and food prices. So let me now tell you a bit about the data we use. This is part of a larger survey by the Federal Reserve Bank of Cleveland, which is run at a daily frequency. And we use a separate module within the survey on inflation expectations. And for this paper, we use category-specific inflation expectations between July 2020 and September 2021. But the data collection here for this project is still ongoing on a daily level. And the survey is, of course, representative of US consumers, and we have a sample size of roughly 18,000 respondents for this project. And, of course, we use some survey weights to adjust for any sampling inaccuracy in the data set. So what do we measure exactly? First, we are concerned about households' aggregate macro-inflation expectation over the next 12 months. That is households' expectation for headline inflation in the coming 12 months. And here we rely on the canonical measure, or the canonical question format by the New York Fed Survey of Consumer Expectations. I will show that to you in a minute. Second, we measure category-specific inflation expectations. To do so, we split the whole range of consumption expenditures of households based on the PCE measure into 11 different categories that cover the whole consumption of households. And then we ask them about each inflation, for each category about their inflation expectation, but we also elicit some category weights for each respondent for these categories by asking them how much dollars they spend in a typical month on those categories, and we also ask them how important they would rate those categories for their personal consumption. And lastly, we also ask households about the spending plans over the next 12 months in order to estimate some Euler equations. So let me first remind you about this traditional conventional measure of inflation expectations from the New York Fed Survey of Consumer Expectations. Here households are asked if they expect inflation or deflation over the next 12 months, and once they indicated the sign of the expectation, they are then asked to give a numerical value to that in a follow-up question. For the category inflation expectations, we try to build on that methodology and to stick as closely as possible in eliciting those expectations. Here we again ask households how they, over the next 12 months, expect prices to change, and then we tell them about which category we are concerned with, for example, motor vehicles and parts, and we give them a small example, here for example cars and SUVs, in order to ensure that they really understand what we are concerned with. And then again they can indicate if they expect an increase or decrease in prices and by which quantitative amount. And we do that for 11 different categories. So before I start to go deeper into the results, let me first show you in this figure how we conceptualize inflation expectations. Households have some information set, and then they use, based on this information, 3 different functions: P consumption, P aggregate, and P category, to form their spending plan expectations, their aggregate inflation expectations, and their category-specific inflation expectations. And those 3 elements in red here are those elements we elicit in the survey. And we can then first test about the consistency between the category-specific inflation expectations and the aggregate inflation expectation by studying which function A, here in blue, is the best aggregator that maps those category expectations, those micro expectations, into the macro expectation, and whether this aggregator is a somewhat rational aggregator that is building on households' expenditure shares, or if it's more behavioral aggregator that matches the headline inflation expectations of households best. And secondly, we test for the external consistency, where we estimate an Euler equation in order to find which measure of inflation expectations, either the conventional aggregate measure or any aggregated measure based on the category-specific inflation expectations, explains household spending plans best. So let me now tell you first about the comparison between the aggregate inflation expectation and the category-specific expectations. Here we find that the macro aggregate expectation exceeds any micro inflation expectations. That is, there's a higher aggregate mean for the conventional measure than for any category mean. This is also true for the disagreement. Households disagree more about the headline inflation rate than they do for each of those categories. And if we look at the time series volatility, we also find that the macro inflation expectation is more volatile over time on a daily level than the micro expectation. And yes?
Do you ask the macro question to aggregate after you ask the categories or before, or you randomize?
It's a good question. So in the survey we ask the macro inflation expectations question before the categories, but we also randomized this for some time, and we found that it doesn't make a difference which order we take here. Yes? If I got you correctly, this is about realized inflation, not expectations. So we understand these results that the micro category specific expectations are just better understood by households. If you ask them what the price of food might be, they have really an idea on this and can give you a more precise answer for this than if you ask them about headline inflation expectations that might be subject to a lot of more heuristics in the expectations formation, because it's just less well understood, this abstract concept by households. If we go to a micro level, there's a very important insight, because we find that for 40% of households, the aggregate expectation they give us lies outside of the range of the category expectations. That is, it's either larger than the largest category expectation or smaller than the smallest category expectation. And for those households, 40%, any linear aggregation or linear mapping from the category-specific expectations into the headline expectation is impossible. Let me show you some numbers. This table shows you the mean of the inflation expectation in the first column in our sample period. Second column gives you the disagreement, that is the cross-sectional standard deviation, and the last column gives you the time series volatility for the daily time series. And here we see that, for example, the aggregate expectation is 5.16% in our sample period, whereas the highest category expectation, gasoline and energy products here, is 4.58. So it's significantly smaller than the aggregate expectation. Same holds true for disagreement. Here is also energy products that households disagree on most, and those also have the highest time series volatility. But it's still smaller than the disagreement and time series volatility for the aggregate inflation expectation. So in the next step, we take those micro expectations and aggregate them with certain weights to aggregated inflation expectations, because those aggregated inflation expectations then serve as a second measure for headline inflation expectations of households, which can be directly compared to the macro expectation. Here again, we find that beliefs of households are internally inconsistent. The macro expectation for headline, that is the reported headline expectation, is larger than the aggregated micro-based expectations and also more volatile. In addition, we find that non-core inflation, that is gas and food prices, price expectations of households, provide the best fit for their reported headline inflation expectation, that is, match the headline expectation closest. And I will show you that the aggregation inconsistency between the headline expectation and the aggregated micro-based expectations varies with households' uncertainty and some social demographic factors. Let me first tell you a bit more about what we mean by aggregation. We use a set of weights, omega here, to map the category-specific expectations into a measure of headline expectations. And we use different sets of weights, which we group into two categories. First, plausibly rational aggregation mechanisms, for example, expenditure weights, which are based on the question for households on the dollar amount they spend in each category in each month, or we use the importance weights, which is also a related measure, or we refer to official PCE weights, which are also similar because they reflect expenditure, but do not have an individual component to them. And those plausibly rational aggregation schemes can be seen as a sort of rational benchmark, because these are the weights we would also use in a model. We also rely on some behavioral aggregation mechanisms. For example, we use equal weights for each category for all respondents, which just reflects that households might not care about weights and just aggregate up or sum up all the categories. Or we refer to the highest or second highest category expectation, which might reflect some salience of high price changes for households. Or in the last set of weights, we only use the non-core inflation expectations or the core inflation expectations. That is, we only use gas and food prices because they might be especially salient, or we just exclude them. And these two scatter plots now show you the distribution of aggregate, that is the reported aggregate inflation expectations on the vertical axis, and the micro-based measure on the horizontal axis. And the left figure gives you the three plausibly rational aggregation mechanisms, whereas the right figure, the behavioral aggregation mechanism. And I think it's clear to see that most of those points lie above the 45-degree line, which indicates that the reported headline inflation expectation is larger for households than the micro-based measure. At the same time, it is obvious that at least for moderate inflation expectations between, say, 0% and 20%, the relationship between both measures is very linear. It's only for the more extreme values of inflation expectations that the relationship between both measures is less strong. I can also show you the time series for inflation expectations. And here you see that by the black line, this gives you the reported aggregate inflation expectation. And you see that this, for most periods of the time, is significantly larger than any micro-based aggregated measure of inflation expectations, except for the max operator here in the right figure, which is just the highest category expectation that a household reports from the 11 categories. And this is somewhat by construction that this is larger than the aggregate inflation expectation. But we also find that non-core expectations here, that is households' food and gas prices, match most closely with the headline inflation expectations. So we find that, of course, that there is some inconsistency here. You have all seen the figures. The reported aggregate is larger than the micro-based measure of inflation expectations. So we want to understand a bit better the drivers of those inconsistencies. So we look at individual level inconsistency for each respondent. We construct a measure here, which is just the difference between households' reported aggregate inflation expectation and any measure of aggregated inflation expectations. On this slide, I will focus on the expenditure-weighted aggregated expectation, but this is generalized to all other weighting schemes. And we then run a regression on the absolute value of this inconsistency to understand better what drives this discrepancy between both measures. And we estimate a regression on a rich set of covariates. I show you here the most important ones in the table. We find that this absolute inconsistency of households is smaller if households are older or if they have higher education. This reduces the inconsistency of households. And this points in the direction that there might be some mechanism of mental abilities of households that if they are more educated or if they are older, then it's easier for them to aggregate up those category-specific expectations into the headline expectation and be consistent. At the same time, we find that the inconsistency increases with two different measures of task complexity. First, we include in the regression the dispersion of those micro-category inflation expectations. That is, if those numbers are more dispersed, it's much harder for households to aggregate up, and they get more inconsistent here. The second measure for task complexity is the macro inflation uncertainty. Here we use a second probability density question where we elicit households' inflation expectations and take the standard deviation of this question to gain a measure of subjective uncertainty about inflation expectations. And if households are more uncertain about the headline inflation expectation in the future, they will also be more inconsistent here, which points also in the direction of task complexity as a driver of inconsistency in our results. As a last step, we want to really understand those two measures, they differ, but which one is more useful actually to elicit also for monetary policy. Therefore, we elicit spending plans of households in the survey, which enables us to estimate an Euler equation on the cross-sectional data, and we estimate several different Euler equations each time using a different measure of headline inflation expectations, either the conventional measure of headline expectations or one of those micro-based aggregated measures. And we will then compare those regressions, that is the model fit of those regressions, using the Aggregate information criterion to find the best fitting measure of headline inflation expectations. And this table shows you our results. The first column gives you the estimated intertemporal elasticity of substitution, whereas the second last column gives you the Aggregate information criterion. And basically we have two main results here. First, the model fit is better for any of those micro-based expectations. That is, those explain the spending plans of households better than the reported headline inflation expectation, the aggregate measure here in red. So irrespective of which weighting scheme we use, those micro expectations explain spending plans better. And if we compare those micro-based expectations, it's actually gas and food price, that is non-core inflation expectations of households, that provide us with the best fitting measure of inflation for the spending plans. So let me wrap up my talk. We conduct a survey on disaggregated household inflation expectations, and we find that those micro-inflation expectations are less volatile over time and also less dispersed in the cross-section than the macro traditional measure of inflation expectations. The inconsistency is related to salience and complexity of the aggregation task, and once we estimate an Euler equation, we find that the micro-based measures of inflation expectations actually perform better in predicting household spending intentions than the traditional macro inflation expectation. This has important implications for monetary policy. First, we find that micro expectations measure the beliefs of households more accurate and are also less volatile. That is, inflation expectations might be more anchored than we usually think when only looking at the conventional measure of expectations. And second, we find that food and energy inflation forecasts are actually the drivers of households' headline inflation expectations and spending plans. And I show in a companion paper that this has important implications for optimal monetary policy, making headline inflation targeting the optimal strategy here. Okay. Thank you.
Great, thank you very much, Alex. We have a few minutes for questions if there are any.
Thanks. I found this super interesting. Recently, I think it was about Germany or the UK, I can't remember, I read about survey results that people seem to be most aware or react to non-core inflation measures, but then in the spending reaction, they react to, it's not that they buy less food, for example, but they put off sales of like luxury spending, like hotels, restaurants, or durable goods. Is this something you have looked into, or you could look into? I think at that time it was just survey results, but you could make this kind of results more robust. I think this would be something very interesting.
Thank you. So we only have the spending plans for total spending, services spending, and non-durable spending. But for all three measures, it's the same, that non-core inflation expectations, that is households' food and gas price expectations, are really driving spending, not just for food and energy, but really for aggregate spending. We interpret this as that households really use what they observe in terms of gas prices or food prices in the grocery store as their measure of aggregate inflation expectations.
So this is a joint work with Victor. He's a PhD student at Insper in Brazil. So what is the idea of this paper? Most of the literature on price setting is based mainly on two frictions, say physical cost, and then we talk about the manual cost and so on, or information friction, talking about rational inattention, stick information, the work of Ricardo Reis, the work of Sims. But then you have another literature addressing what happens within the firm, and then how communication happens within the firm, what are the problems of misalignment within the firm, and how could this affect price setting. And this paper is about that. It's trying to get a little bit the structure of the firm and trying to understand what happens with price setting and with aggregate pricing when we incorporate that. So our views here will be trying to understand firms' incentives, so the guy that sets prices, the employees, how they have misalignment of incentives, as well as how communication evolves within the firm. And then when you start looking at this, what do we get? I guess that is the question of the paper. So we derive a new Keynesian Phillips curve and so on with this incomplete information. So we don't impose a stickiness. The stickiness arises from this misalignment within the firm. And we show that it is exactly this misalignment that generates both the price stickiness and the non-neutrality of money. From there, I mean, once you have a Phillips curve, we show what is the optimal policy, what is the welfare of the economy. We derive a Phillips curve, and then we discuss how the Phillips curve depends on the structure of the firm. So if the firm has a lot of divisions, if the firm has a lot of employees, how does it get? And it relates to the multi-sector models of price setting. This is the idea. So what can our model do, and what do we have? So our model manages to explain some of the aspects on the literature on empirical price setting. So we have both the model, and then we have an online database of 6 major retailers in Brazil. We scrapped the whole website for 4 years, and then we look at how this compares to our model. So if what we get from the model is explained in the data. And we managed to explain small changes in prices, some heterogeneity on price setting. For instance, food prices are more frequent. The discussion of reference and sales prices that it's been also on the literature, and we also managed to explain how a misalignment of information within the firm helps you understand what is the stickiness, and I'll try to get there. Okay, and on the macro side, I guess I've already discussed a little bit. We generate non-neutrality of money, and we relate how is the power of monetary policy to the number of sectors in a firm. So sectors here, I'll try to explain a little bit, but it's within the firm, and then optimal policy. So what is the idea? The idea is you have a firm, and this is like the simplest way. You have a firm, you have a boss, and this guy has 2 departments. And the point is, this department knows something of the shock, and he has to reveal it to the boss. this department knows something about this shock and has to reveal it to the boss. This is the idea. Contracts are not contingent on the information. So you can think that there is some misalignment. So for instance, this guy knows something about, I don't know, say idiosyncratic shocks. So he learns a little bit about how's the demand shock. And then he has to reveal it to the boss, and the boss is the one deciding on the price. Okay? So this is the idea. Maybe here you can think of this being a macro shock. And this guy has to tell the boss what is the macro shock. And then what happens is, once this boss got the message, both from Department A and Department B, he has to set the prices. And the whole idea will be that how it's going to be this message. How this Department A, when it gets a shock, it reveals to the boss. So basically the idea, and here it's going to be an equilibrium based on micro theory. So I'm going to be using chip talk equilibrium. And the chip talk equilibrium, just to give a background, it tells you that the equilibrium will be partitioned. So even though the shocks are continuous, the way that this guy decides optimally to send the messages, it partitions the interval. So for instance, you can think that the shock is a uniform 0-1. And then, depending on the misalignment of the departments, he'll decide to say, well, just if the shock is low or the shock is high in equilibrium. And if he does that, I mean, it becomes obvious that you start getting stickiness, right? Because sometimes the shock is changing, but the guy is not revealing a change on the message. See my point? So you're losing information when you're revealing to the boss. And when you lose information, you start getting stickiness. And then this is like the intuition, and then we start building, well, what if the shock is persistent? What if the shock is correlated? What if, just to make things look more like the data. But this is the intuition of the mechanism. So the department, as I mentioned, it has private information on one margin. The information about the other margin is given, so each of them knows something, and you have a profit function, and there is a misalignment on the profit function. This is the important part. If everything was aligned, you would review everything. There has to be some misalignment between what a department believes in or gets the money out and the CEO. So one aspect is think that there is a sales department. The guy has a profit based on revenues, and the CEO has a profit function or an objective function depending on profits, things like that. Or I care more about the sales of my department and not about the firm. These types of things. So you can think of many different misalignments within the firm that would help to explain this structure. Okay. So the idea would be you have a micro department, and he's maximizing based on this shock, on this informational here, and the macro one based on this shock. And then the problem of this boss that decides prices, it has to really think about the messages that he got from the employees. So what we do? What we do is try to get the optimal price in a symmetric equilibrium with full information. We do quadratic deviations, and then we go on quadratic deviations from there on. This is a bit like Makoviak Wiederholt have done it using these quadratic approximations. And basically, what we will be doing is to say, look, the price of a department, the price of the CEO will depend on the steady state one or the full symmetric information, and then deviations, right? It's a Taylor approximation. And then the deviations compared to aggregate shocks and idiosyncratic shocks. So you can think like The micro department knows about this. The macro department knows about this. And what are they misaligned? They are misaligned about what is the weight that they put on each of the shocks. So if they care a lot about idiosyncratic shocks or if they care a lot about macro shocks. I guess that would be one way of seeing it. And if you have a high misalignment, it's going to be less informative. And if it's less informative, as I mentioned, it becomes more sticky. Prices become stickier. So, yeah, I guess that's it. So what is the game here? You have the loss function of the boss setting prices. You have the loss function of the micro department setting how it would like to be. And then the question really it's about this and about this. These are the misalignments, right? How much one cares, what is the sensitivity to one shock or another. And now we have this quadratic functional form, 3 payoffs. The simple paper that started this was Crawford Sobel in the 80s doing chip talk. And there you had 2 players, static game. Here we're using Battaglini because he allows for this continuously bidimensional shocks. So we can use 2 shocks here, uniform, still static, and then we add persistence later. But this is so we're getting the results from Battaglini, which tells you that there exists a partitioned, almost fully revealing equilibrium. This is just the lemma. It's the lemma, just like Crawford Sobel. So what is the idea? You're getting a shock, a micro shock. You're getting a macro shock. The guy the CEO has to decide the price and how it's gonna look like this price. This is the question here. This is the Mickey Mouse model, right? Then we do the general equilibrium. But on this Mickey Mouse model, you get this. And here, I mean, I'm imposing parameters. It's just a Mickey Mouse. But what do we get? And I'll try to give some intuition for this result, which looks like a little bit like what we see in the data. You get that if it's a change on the macro shock, you get from this one to this one. And if it's a change on the micro shock, you're getting these small ones. So with 2 types of shocks, you can explain the reference sales and you can explain the small price deviations. This is a bit the idea. Because more than that, the shocks are continuous, but because of message being sticky, because the message is partitioned, you start getting stickiness, nominal stickiness. Okay, go ahead. If you have trend inflation, know if here I'm doing everything deviations from the symmetric one, so it would be sticky compared to the trend deflation. So probably things would change. What else? Then we get this Mickey Mouse model, and we put it in a dynamic model, and we add 3 dimensions. We add persistent shocks, we add multi-sector, and we add and we construct a new Keynesian DSG. Okay? So here I'll try to be a little bit briefer, but what is the problem here? The firm is maximizing profits as usual, but now I'm putting a lot of goods. Okay, this is just the idea. So there is omega, the set of goods, and psi measures all the parameters that get the misalignment. So the the point that we want to make, and we have two types of firms that we discuss in the paper. One is, you can think of a bunch of goods, and you have a misalignment on each of the goods, and then you have one shock for each good, and then you have one guy that is a macro shock, one guy that looks at the aggregate. Or the opposite, you can think of, we have sectors, subsectors, categories, and from there you explain a good. So you have the shocks, sort of a hierarchical way of doing it. Okay? Here we're working more on this hierarchical, but we have also the other way. So you get the prices for each of these goods, and you aggregate. So once we aggregate, we can get just like a usual Phillips curve. And there's nothing very fancy here. It's just algebraic. I guess the interesting part comes from the coefficients that we get on this Phillips curve, that they depend on how the deviations were on that Taylor approximation, how the deviations came, on how the optimal prices depend on the micro shocks or the macro shocks. And what I'm telling here is that the Phillips curve here depends on the misalignment. So it's going to be really the misalignment that generates the stickiness, and the misalignment is the one, is what is driving the slope of this Phillips curve. This is the idea here. Okay, so it's going to depend on the misalignment will depend on the number of divisions as mentioned, and I think the big intuition is the less informative is communication, the higher is the misalignment, and if higher is the misalignment, the steeper is the slope of the Phillips curve. So it's really a story of losing information within the firm, and when you lose information within the firm, the Phillips curve becomes steeper. What else?
Steeper or flatter?
I thought it was steeper.
You get more stickiness in the aggregation data.
You get, sorry?
More stickiness, no, that's what you were suggesting.
I get more stickiness, it should be flatter. You're right, sorry. Less informatives, yeah, flatter, sorry. Okay, so the other part of the general equilibrium is standard. So just put an IS curve. You can add a Taylor without anything very interesting. Just to try to start looking at, impulse response functions, see how this model will give you more persistent or not impulse response functions to monetary policy, these types of things. I will not be showing here, but we have the results. Okay? We have a result showing that actually the effect of monetary policy depends on the number of sectors. This is something that we have been looking at. I think it is related to the stickiness. So it's a way of seeing the stickiness, because when you have more sectors, you are reducing stickiness, because it's like a bunch of shocks. You learn more about the information within the firm. But this is something that we have been looking at. Okay, so this is a bit of the theoretical part. Then we go to the empirical part, trying to see if the model fits the data. And what do? We get daily prices from online and offline retailers, mainly online, okay, a little bit of offline. 6 major supermarkets in Brazil, 6 million observations. We scrapped the websites for all these supermarkets. And then a couple of things. So these are the numbers of products that we get in each of these supermarkets, roughly, 30,000, something like that. This one is the large one, but the others are about 30,000. What I wanted to show, I just wanted to explain a little bit this. So I have all these products, and I need to map it to the model. So what do we do? In our model, as we have sectors, categories, subcategories, you really need to label them and say that a macaroni, rigatoni, whatever, is a pasta, and a pasta is a food, and a food is within inflation. So what we do is that we map all these products into the CPI labels. See what I mean? So in the CPI you have the aggregates, as you were saying, like the services, foods, and so on. So what we do is we get this supermarket, roughly 8,000, 20,000. We manage to do it manually. So we look at the name of the product and we say, okay, this product, macaroni pasta, is a pasta. Pasta is within whatever in the CPI index. And so we do that in the first place, and then we do a supervised machine learning with n grams, 3 n grams, trying to understand, based on this text that we said manually what it was, try to forecast the names of the other products. So for instance, if rigatoni, I labeled it as pasta, is spaghetti pasta, probably because you have Barilla, 500 grams, and so on, it learns that it's pasta too. And so we managed to get these millions of observations and put it into the same system as the official index. Did you get the intuition? Okay. So this is a bit of what we do. And once we've done that, we can simulate. So, and then the question is, how many partitions do I have? Because this is the hard part. So the whole idea was that there is a number of partitions in each of these shocks. So in the aggregate, in the micro shock, and so on. In each of them, I have 3 partitions, for instance, or 4 partitions. And I need to map it, the data that I have, into the model. What I do is I assume that it could be from 1 to 10 partitions in each of the shocks, in each of the dimensions. And from there, I see which one is the best one, which combination is the best one. So it's like it's a maximum likelihood brute force, in a way. So doing all the possible combinations of numbers of partitions. So for instance, I'm looking at tomatoes. So tomatoes, I could have, for instance, 2 partitions in food, or 4 partitions in fruits, and 3 partitions in tomatoes. The number of partitions in each of these will depend on the misalignment on the firm. So, for instance, the guy that looks at the shocks in food has a high misalignment compared to the CEO, there should be few partitions. If the guy that looks at shocks in fruits doesn't have much of a misalignment, we should have a lot of partitions here. And the fact that we have labeled all the products to the CPI index, we managed to disentangle what is the shock on tomatoes, what is the shock on fruits, and what is the shock on food, for instance. And then what we do is we run all possible combinations of 1 to 10 partitions in food, 1 to 10 partitions in fruits and tomatoes, and for each of these products. And then try from this combination, try to get what better explains the prices that we have for each dimension. So what we see that some of the prices have very small partitions, so it's as if you have a lot of misalignment. Here we're looking more at supermarkets. We have a little bit of durable goods, but it's more supermarkets. And you have some that you have a lot of a lot of partitions, which would suggest that you don't have much misalignment. Let me try to give the results here. So this graph would show what is the relationship between misalignment and partition. So just, I guess the theoretical part would already show that the higher is the misalignment, the smaller is the number of partitions that we have, the higher will be the stickiness. And finally, could the model explain the data? So just getting 4 possible products here. So you can see that the green one is the simulated price, the blue one is the actual price. It matters to explain pretty well. Obviously, there are many dimensions. So once you have a lot of dimensions, you can explain well the data. But it manages to, the way we got these 4 products is you manage to explain the reference sales, you manage to explain small deviations or a discount, these types of things the model can explain. The model will tell you, okay, this happened because there was a shock, for instance, on the soap powder, or this happened because there was a change on foods, these types of things that we would explain from the model. So just to sum up, it's a dynamic model based on within firm communication, and it helps us getting the nominal stickiness, explain some of the price setting dynamics and real effects of monetary policy, and empirically sales and references, small changes, heterogeneity, and the relationship between the misalignment and the number of partitions.
So I was first thinking maybe the boss is going to try to solve this misalignment problem. Firms are aware of this. But then I was thinking maybe this is just an inherent feature that you can never get rid of, and maybe the problem is worse than what you're saying, right? There's so many levels in a firm, and especially in large firms, you can think that this is a...
So
then I'm wondering why prices move at all, almost. Yeah.
So a couple of things. First, if contracts were optimal, if you could set all the contracts based on the shocks and so on, there wouldn't be stickiness. And so optimal contracts and so on would solve this problem. But I guess in real life, it's hard to get an optimal contract within the firm for all these possibilities. The second one that I think it's worth looking at, as you mentioned, is trying to explain this mechanism. Do we really see, for instance, and that's something that we're looking at, for instance, supermarket brands, probably supermarket brands have less misalignment because you are within the firm compared to say, brands coming from outside. So should we see more stickiness or less stickiness? So we're trying to understand these types of things. Or because we have, the data is only on the supermarket, so we cannot look at small versus large to see the stickiness within the firm if it's higher in large firms. But then we're trying within the data that we have on supermarkets to see if we see something, if this idea that we can get a proxy of misalignment in the firm and compare it to the stickiness.
Yeah, the problem might be also a little bit different or more like that in the production side, right? Like this, where these things really exist.
Are there other questions?
Actually, that the first question made me think of a follow-up question. There is an additional complication because, I mean, with the boss trying to figure out what exactly the information is, in supermarket setting, it's the prices of other competitors is very apparent. It's very clear to gather, and then you can get information by the prices set by the competitors, and so that could complicate things for you.
That's true. That's true. Here we're not doing a dynamic model of competition, right? It's a representative.
Thank you for a very interesting presentation. Just a question, and maybe you said this and I missed it, but what do you think would be a source a sort of deeper source of this misalignment? Because it can't just be the number of divisions in the firm. That seems too trivial.
For me, I think it's that the incentives are not completely aligned. So you can think of a sales department, or suppose that you have regional departments. The guy cares if it sales on the north, the other cares if it sales on the south, and the CEO has to set one price for all the country. This generates a misalignment, and this misalignment will generate sickness. So it's anything that you can think of, for instance, on bonuses, that it's not exactly the same objective function. So it could be regional, it could be I care about sales, the other care about costs, the other care about profits, these types of things.
Can you give us some intuition about optimal policy, monetary policy from here? Like that this has like very heterogeneous effects on different firms. How do you understand the welfare implications of this setup?
So on the algebraic, it doesn't change much, because once you have the stickiness, it's just the parameter of the stickiness. It's not based on a Calvo, it depends on the misalignment, and then everything that you talk about, say on a Calvo parameter, you would be talking about here with the misalignment. And then you'd say, oh, if there is a higher misalignment, what would happen with the welfare function, this kind of stuff. So that would be assuming from the Phillips curve, right? I have a standard Phillips curve, so it's a change on the parameter. I guess the second point would be, how could you get out of this price stickiness? And then it would be much more about setting the contracts optimally and trying to reduce the misalignment within the firm. That would generate welfare.
Can you just say something about the volatility of inflation in general? If that goes up, does your model predict that the Phillips curve will be flatter?
The model predicts, sorry?
That the Phillips curve will be flatter if prices are more dispersed? So that seems to go against the current environment.
It would show that the higher is the misalignment, the flatter is the Phillips curve. So it's not about comparing to the actual data, it's just in the model.
But wouldn't they get more dispersed signals, the micro and the macro?
I mean, we want it calibrated, so I didn't show calibrations here. I guess only comparing the calibrations with a Calvo that I could say if it's flatter or not compared to a...
So there has been a widespread consensus that of a secular decline in the natural rate of interest, R star. And there's a paper by Laubach and Williams and others. And because of the zero lower bound constraint, that means that there would be an increased incidence of binding ZLB episodes and therefore greater macro instability. So that's an important consideration. In the existing literature has studied optimal monetary policy under a zero lower bound, but when the natural rate has a positive mean. And so in these cases, in normal times, the natural rate of interest is positive and the policy rate is above zero. Okay, and so the central bank successfully stabilizes inflation and the output gap. Occasionally there are episodes when the natural rate of interest fall below zero, and in this case the policy rate is stuck at zero and there is some macro instability. There is an important role for forward guidance, as we know from Eggers and Woodford and Goodman earlier in this promising lower for longer. Now, what we do in this paper differs in that we study optimal monetary policy under a zero lower bound constraint, but when the steady state natural rate of interest is negative. And so this is a situation when the new normal is one with a negative natural rate of interest, but occasionally the natural rate does jump above zero. And this is this is consistent with Summer's speech about secular stagnation. So what we do in this paper is we ask two questions. One is, what does the optimal monetary policy look like in this environment? And secondly, what are the implications for macro outcomes? So in this talk, I will characterize the optimal monetary policy problem. Then we'll discuss equilibrium under the optimal policy in the case of a constant natural rate. Then we study fluctuations in response to natural rate shocks, and then we'll discuss the issue of implementation in this model and conclude. So, in the interest of time, I'll be brief about the related literature. There has been a number of papers that studied the problem of the zero lower bound on the policy rate under commitment when the natural rate of interest is positive on average, so Aggregate and Woodford and others. There are papers discussing the optimal choice of an inflation target conditional on a given interest rate rule, as Coibion and Cauters and others. And it's also related to a strand of the literature that studies equilibrium determinacy in regime switching models, as David Leeper, Farmer, and other economists. So this is the problem that we study. The central bank tries to minimize the discounted stream of losses from inflation and output gap deviations, square deviations from target, subject to the standard Phillips curve and the IS equation. Okay, we have the zero lower bound on the policy rate, and the natural rate of interest follows an R1 process with a negative mean. Okay. Now, a brief detour, some may be surprised how come the natural rate of interest is negative on average. What does that mean? The micro foundation, one possible micro foundation for this to occur is based on the idea that households are not infinitely lived. And Jordi has a paper in the AJ Macro where he studies a New Keynesian model with overlapping generations, and in which consumers have a constant survival rate for life and activity survival rates, gamma and nu. And so there is a probability of going into retirement, okay, or inactivity because of skill obsolescence or illness or just retirement. And the objective function of a consumer born in period S is this one, where beta is the discount factor and Z is a shock, an R1 shock process. And importantly, firms are attached to the founder, so they also have a survival rate of gamma nu, so that assets are finitely lived. And so one can show that in steady state, the equilibrium real interest rate is equal to rho, where rho is related to beta as here, and plus the log of nu. So importantly, beta and R star are now detached, and you could obtain a situation when R star is negative, whenever this activity survival rate is sufficiently below beta. Okay, so when there is a high enough probability of retirement or going into inactivity, the intuition being that this expectation of declining income in the future that reduces the present discounted value of income, and so consumption has to be lower, and to restore equilibrium on the goods market, the real interest rate has to be lower. Or said in other words, in aggregate saving, there is a desire to save more, and so this depresses the real interest rate. So Jordi shows in his AJ macro paper that this economy boils down to the following linearized equilibrium conditions. where we have a standard Phillips curve, except that the discounting here is now done by beta gamma in a standard IS equation, and the difference being that the natural rate of interest now oscillates around the negative mean. So coming back to our problem, with a slight reparameterization of beta here, we are basically back to the standard Newcasey model, with the two differences being the policy rate that is bounded below by 0 and the equilibrium real rate being negative. So how do we solve this problem? We form the Lagrangian and derive the optimality conditions with respect to inflation here and respect to the output gap. Okay. Then we have the standard complementary slackness condition here, which says that the Lagrange multiplier on the S equation must be non-negative, and either the Lagrange multiplier or the nominal interest rate has to be 0. So the product of the two is 0. And initial conditions being that these Lagrange multipliers are 0, so there is no, in period 0, there is nothing that you have pre-committed to. Okay, so first let's look at the steady state of this problem. The assumption here again is that this R star is negative, and so in steady state this has to hold. Okay, this comes directly from the first order condition with respect to inflation. Okay, here, and then this has to hold from the first order condition with respect to the output gap. And now you can see that, well, first of all, inflation must be greater or equal than minus R star, okay, from here. Okay, this now becomes just, this is what comes from the complementary slackness condition, okay. Here we have RTN and inflation, these things cancel. And so we know that R star is negative, so inflation has to be strictly positive now, because this has to hold. Now, if inflation is strictly positive, then because this is just proportional to inflation, this Lagrange multiplier must be strictly positive. But if the Lagrange multiplier is strictly positive, then the policy rate has to be equal to 0. Okay, this is from here, from the complementary slackness condition. And so from here, it means that inflation must be equal to the negative of R star. So we have a steady state in which there's positive inflation. Inflation is equal to the negative of R star. The policy rate is stuck at 0, okay, and this Lagrange multiplier is positive. So let's look at transitional dynamics in the absence of shocks. So we write now the model in deviations from steady state, where we have suppressed the shock process now, and there's no expectation. So this is perfect foresight transition path, and we simulate this economy for a calibration in which this is the intertemporal elasticity substitution, this is the time discount factor, kappa is the slope of the Phillips curve, and then this eta is, what was eta? The coefficient of the output gap in the loss function, that's right, yeah. Okay, and the natural rate of interest is minus 25 basis points or 1% per year. So this quarter calibration. Okay, so so these are the transitional dynamics. Now you notice that inflation starts out negative and then gradually converges to the steady state with positive inflation, which is equal to minus R star, okay, 1%. This is accompanied with a gradual decline in the real rate from around 0 to minus 1% to the natural rate of interest. And throughout this path, the policy rate is actually constant at 0. There is no movement in the policy rate at all. And the output gap also starts negative and converges to a slightly positive value. Okay, so why is this an optimal path? Well, recall that in this model, optimal inflation is 0, okay, and so this path allows the central bank to maintain inflation closer to 0 for some period before it converges to the steady state in the absence of shocks. Okay. Then we look at the stochastic equilibrium in the presence of shocks, and here we have again the model in deviations from steady state, but now we have put back the shock process and we have the expectations, and now we need 2 additional parameters to calibrate, which is the persistence of the shock process and the volatility, the standard deviation of the shock to the natural rate of interest. And so under this calibration, this is the picture that we get. Now you see that in response to oscillations of the natural rate of interest, which is the black line in the top left panel here, now we see a smoothed oscillation of the actual real interest rate. Okay, this is the blue line here, so it's less volatile. And again, we have a policy rate which throughout is 0, so it's constant. And inflation oscillates, has second best fluctuations in response to the shock, and basically the actual real interest rate is just the inverse of inflation because the policy rate is constant. And also the output gap exhibits second best fluctuations around the steady state. Now,
Anton, sorry to interrupt, but
yeah.
I forget this question. So if there is a very persistent shock, you will still get a policy rate that's flat.
So I was just going to say that this thing that the policy rate is flat is not a general result, and in fact, if you vary the persistence or in this case the volatility of the real interest rate, of the natural real interest rate shock, then you do get occasional episodes when the policy rate goes above 0, but these are relatively few and short-lived. And you see that when these episodes happen when the natural real rate is relatively high and it was not preceded by periods of very low natural negative real interest rates. And in these times, the central bank actually is able to achieve better inflation outcomes in the sense that inflation is closer to 0 than at other times. So one could be surprised by this optimal policy result in the sense that it's characterized by a policy rate that is stuck at 0 for most or all of the time in our baseline calibration. And therefore, one could wonder what guarantees determinacy. How could central bank ever implement this kind of policy if the only thing it controls is the policy rate? How can it implement this solution? And so one candidate rule, of course, is to set IT equals to I star, where I star with starred variables now denote the equilibrium outcomes under the optimal policy, okay, the equilibrium nominal rate, output gap, and inflation. And we know that this, however, would not deliver uniqueness of equilibrium. It would result in multiplicity of solutions in addition to the desired one. And so we want a policy rule that guarantees that I star, Y star, Pi star is the only equilibrium. And what we propose is a rule of this type where now the policy rate follows a regime switching rule where the coefficients on inflation and the output gap vary depending on whether inflation and the output gap in deviation from the optimal path is positive or negative. So, for example, when inflation in deviation from pi star is positive and the output gap in deviation from y star is positive, then these coefficients are positive here. When both inflation in deviation and output gap is negative, then we have negative coefficients here. When inflation is positive, here is positive, and then you get the idea, okay? So more compactly, one can write this rule as such, where now these denote absolute value, okay? So that the nominal interest rate here responds positively to any deviation of inflation from the equilibrium value or the output gap from the equilibrium value. And this guarantees that the nominal interest rate actually is bounded below by zero, that it's not negative. Okay, so because of the absolute values. Okay. Now then we have the non-policy block, which in deviations from the optimal path look like this. And then we can write a system in this form where the matrix AT now is time varying, and these are the four cases. We have these four matrices A1, A2, A3, and A4, and then the idea is to find sufficient conditions for determinacy of equilibrium, for uniqueness equilibrium, when you have this kind of system. And so this is a section of the paper that deals with these kind of systems, and here you see that AT is an element of a set A script, which can contain several of these matrices up to Q, but it must be a finite number of matrices. And so the goal is to establish sufficient conditions on this set that guarantee that xt equals 0, okay, that the deviations from the optimal path are 0 for all t is the only bounded solution to this equation. And so another way to state this is that the limit of the norm of xt plus cap t, where cap t goes to infinity, is greater than some arbitrary large m times the norm of xt for any m positive and xt different from 0, where this is the usual matrix norm, Euclidean matrix norm. And so there is a theorem in the paper that shows that under certain conditions, namely this alpha, which is the maximum of these matrix norms of the matrices A1 to AQ, is less than 1, then this is sufficient for xt to be equal to 0 for all t as the only bounded solution. Okay, the proof is somewhat technical and it's not so interesting here, but the important thing is that what we derive is not a necessary and sufficient condition, but it's just a sufficient condition, and as such, the determinacy regions, which are shown here in these blue shaded areas, are subsets of the standard determinacy regions. In particular here, you have the case where the phi pi and phi y's are all equal, and you can see that the gray area here is the one which would be the standard maximum eigenvalue condition for determinacy, and we have a subset here, which is the blue region here. Okay, so one point to discuss here is the issue of time inconsistency. We saw for the optimal monetary policy intercommitment time 0, and so of course there's the usual problem that this policy is time inconsistent. Central bank, if it's given an opportunity in the future, would try to re-optimize. And in particular, it may want to, in our case, with the rule that we have specified, it will always make promises to deviate positively with the policy rate, regardless of what happens to inflation and the output gap, whether they are above or below the optimal paths that optimal commitment solution So this means that a central bank may find itself in a situation when inflation is, say, too low and the output gap is too low, and nevertheless it threatens or promises to increase the nominal rate, okay, which may have some credibility issues. The central bank is responsible to the public and has to explain. Of course, these are off equilibrium threats, so if you believe them, then you will never observe this kind of situation, but this is very standard in all optimal monetary policy problems. So there is nothing special about this. Okay, so we study optimal monetary policy with a zero lower bound when the natural real rate is negative. The optimal policy aims to approach gradually a steady state with a positive average inflation and a binding zero lower bound. Around that steady state, inflation and the output gap exhibit second-best fluctuations in response to shocks to the natural rate, and these coexist with a nominal rate that is at the zero lower bound most or all of the time. The central bank nevertheless can implement this optimal policy as a locally unique equilibrium by means of an appropriate state contingent rule, and to establish that result, we derive a sufficient condition for determinacy in a general model with endogenous regime switches. Thank you very much.
Thank you very much. Do you have questions? No? So I guess my general question is maybe also going back to the panel yesterday, and maybe you can answer this as a non-central banker. Like, how should we think about this model prescribing some lesson for the central banks? And if you want to comment about this, maybe this is safer if I don't ask you, Anton.
The timing of this paper is a bit unfortunate because now, of course, it's all about inflation being too high, and there's this discussion that the natural rate, that the short-term natural rate is positive, but from the lens of this model, this is one of these blips, right? That through the lens of this model, this is one of these occasions when you have a spike, but it's a temporary thing, and then the economy will come back to the secular stagnation, long-term secular trend. Yeah, that's through the lens of this model. I don't know, Jordi, maybe you want to say something about it.
Just to complement this, it's a result that shows that in an environment in which our star is negative, and there's no reason to reject that this is a relevant environment now and in the future. Optimal policy may involve being at the zero lower bound all the time, or most of the time. So, which means that we shouldn't consider it an anomalous situation or a transitory situation, but just a new normal. It's a way to rationalize a zero low interest rate, a continuously zero interest rate as a new normal.
Thank you very much. So I guess we learned something from models. We don't have all of them yet, and maybe we need some more data to see where we are. Are there other questions?
Thank you. Yeah, that was fascinating. I was wondering whether your model informs maybe also the discussion on the optimal inflation target. So I could imagine that sort of steady state zero interest rate is optimal in certain situations, and then you have these maybe large fluctuations around it. Is there a way you could sort of compare the welfare of that sort of environment to just saying we're permanently raising the inflation target?
Here the target in terms of what the central bank wants to achieve is still zero, and that's just because of the standard Calvo friction result that price dispersion is very costly, and so you want to minimize misallocation of resources across different goods and so on. But zero inflation is not possible in the long run here because, you know, it's in the absence of shocks, you have to inflate at the rate of minus R star. I guess for some people, this result of inflation, positive inflation at minus R star, is what some would call inflation target, although that's not, this is what, this is an outcome, but not really a target, right? So we don't have anything new to say about what the central bank wants to achieve in terms of minimizing distortions and you know, deviating from zero inflation. I mean, in this simple Calvo framework, at least.
Thank you all for being here, and thank you, Raphael, for including our paper in the program. I'm going to talk about inflation levels and inattention. This is a joint work with Jenny Tang, and Jenny is at the Boston Fed, so the usual disclaimer applies. All the views presented in this paper, in this presentation, do not represent the official position of the Boston Fed or the Federal Reserve System. So now that we have that out of the way, let me tell you a little bit about our project. And the title really tells it all. We are interested in attention or attention to inflation and how that may evolve or change systematically with the level of inflation. So I want to give you a preview of the contribution of this work because I think that it might get lost a little bit in the details later on in the presentation. So actually there are two main contributions to this paper. The first contribution that I really think it's kind of like getting lost in the presentation, so I want to make it clear, is that we suggest two new measures of inattention or attention to inflation by consumers in the United States. We believe that these new measures that we propose are better suited to study attention than the measures used currently in the literature. And then with those measures, we try to see if there is a systematic relationship between attention to inflation and inflation level. So what's the motivation to look at inflation in attention? Well, as we all know, inflation expectations are very important to determine macroeconomic variables. So if we think about consumption or wage negotiation, expectations are very important. If we take the labor market example, if we think about workers, the higher their inflation expectations, more likely that they are to try and negotiate wages and be also more aggressive in their wage demands. Now, the effect of actual inflation on inflation expectation in an environment like today is very important. How much of the higher inflation that we have at the moment is translated into inflation expectation depends on attention to inflation. So if we continue with the example of the workers, if the workers don't pay attention to inflation, they don't update their inflation expectations when they come to negotiate the wages, probably their demands are not going to be as aggressive as if they were to pay attention to inflation. So this is very important to understand, especially for policy, how attention behaves and whether it changes with the economic environments, and if it does, when it's likely to be high, when it's likely to be low. So that's the motivation to look at that. And so in order to set ideas, we use the standard model of rational inattention by Sims. So kind of like I will give you like the business school version, the kind of like intuition to refresh the concepts here, and then we'll look into more details with this model. So this is the standard model of Sims. We have pi t, which is the realized inflation. We have at, which is the action that the agent is taking. We can think about gamma t as the marginal utility of consumption or real wealth, and lambda, well, I is the cost of information, and lambda, we can think about that as the marginal cost of information. So the individual is looking for the joint distribution f over a and pi to maximize this objective function. So like any economic model, we have cost and benefits. If the benefits exceed the cost, then we pay attention. If the cost, this is the business school version. If the cost exceed the benefits, then we don't pay attention. So what are the things that go into the benefit and the cost? Well, we have the inflation inaccuracy can be costly, so we want to be as close as possible to inflation. We have the marginal utility of consumption, so these two are the reasons that we would like to pay attention. On the other hand, we have the cost of information. We can think about the cost coming from limited cognitive resources. Different people may have different limitations there, and also kind of just searching for the information. So these are the two things. So we believe, or we suggest, that the level of attention will systematically change with the level of inflation. We think that when inflation is high, well, I should also say that we focus on the marginal utility of consumption and marginal cost. We will forget for now that inaccuracies are costly. And so when inflation is high, we think that the marginal benefit of paying attention, that is the marginal utility of consumption, will be higher. Why we think that? Well, at least in the short run, the consumption will decline, I mean, what we can afford, and so we think that the marginal utility of consumption will be higher. So that's in the short run at least. We think that will go up. On the other hand, we think that when inflation gets higher, the marginal cost will tend to be lower. Why would we think that? Well, we can think about some consumers hitting their budget set, so they get the information for free. They realize that prices have gone up, so that will go down. Also, we can think about, coming from psychology, which is in the next slide, we can actually come up with this hypothesis that attention will be higher when inflation is higher from a completely different angle coming from psychology, and that also can explain why information costs may be lower at the time of high inflation. So, but the bottom line is that if when inflation is high, the marginal benefit is higher and the marginal cost is lower, then the two things differ, and then people will pay attention, or more attention, okay? So that is the kind of like the business school presentation of the rational inattention model. And as promised, we could have come to that without any model at all, and it also can explain why marginal cost may be lower when inflation is high. So probably all of you know that if you put the hands in cold water and hot water, and then you put it in a warm temperature, it will feel very different. That is just to say that our sensory system is responding to changes, okay? It's responding to changes. Not only that, psychologists have found that there is what is called the just noticeable difference. We pay attention, or our sensory system is sensitive, paying attention, or like realizing changes when it's above a certain level, so proportional to the initial stimuli. When we take that to price setting, what it means that we will feel the change in prices. We are sensing changes in prices, and we will feel it. It will be more salient to us when it's above a certain threshold, a certain level of inflation. So in other words, we can think about the cost, because the cost of information will be lower when inflation is higher, because we just will feel it. So our sensory system feels it. That's another explanation of why marginal cost may be lower when inflation is higher. And then the hypothesis that attention changes systematically with the level of inflation makes sense, and we don't even need the rational inattention model. So that's a side note. Okay, so going back to the model, instead of working with this more complex setting, we know that the solution to this setting is also equivalent to the individual getting a signal, a noisy signal that is a function of the actual inflation and some noise. The noise is now normally distributed with the mean 0 and variance sigma squared epsilon, and the prior is normally distributed with mean pi tilde and variance sigma squared pi. So having that in mind, basically the posterior will be just a weighted average between the signal and the prior, where m here is our basically measure of attention. So that's the weight that we put on new information. In a fully rational setting, m will just be equal to 1. So we just put all our weight on the new information, that this is just like a signal on the actual inflation plus some noise. So if we have that in mind, and we have m as the variable, or as the kind of like our attention, then we can rewrite this this objective function. We can express that in terms of our attention variable here, mt. So basically, now we can say, what do we mean by inattention? What we mean by inattention, we mean any level m that is less than 1. That is considered inattention. And when we solve this problem, we find that inattention will be either 0 or some positive number, and that positive number is determined by this term here that we have on the bottom. There are two things to this term. Of course, the variance in the prior, as we all know, when the variance in the prior is higher, we will tend to pay more attention. There is a reason to pay more attention. Inflation could go like to the extreme, and so we could be very wrong about it if we don't pay attention, so we have more reasons to pay attention. But what I want to focus, and what we will focus on in this talk, is this ratio that we kind of like call the cost to benefit ratio, and that is basically, we claim that that is changing systematically with the level of inflation. We think that that is going down when inflation goes up, and then if that goes down, also we would like to pay more attention. That's the basic of our hypothesis. So here it is. We suggest that when inflation is high, more people will find it worthwhile to pay attention, or not just to pay attention, but to pay more attention. And then when inflation is low, less people will pay attention or will pay less attention. So this relationship is interesting and is important, especially for nowadays, because what it implies that it's possible that we have a nonlinear relationship or acceleration of inflation. In other words, is when inflation gets to a certain level, maybe it accelerates much faster than we think when attention is not systematically changing with the level of inflation. So of course it's important to know, especially in this environment. So the problem is that measuring attention is difficult, right? It's like hearing and listening. How do you measure listening? It's very, very difficult. So it's difficult in general to measure attention, to inflation expectation in particular, because there is no long-running survey of US consumers that directly ask about inflation. All we have is forecasts. And indeed, much of the literature had looked at properties of the forecast in order to kind of like talk about attention. Problem is that when we think about forecast, it confounds attention with other things like uncertainty. So today is a good example. If many people pay attention to inflation, but if we were to ask them, what do you think inflation will be during the next year, it will be very difficult to give an estimate, and probably people will be very wrong. The reason is that we don't know what will happen with the war in the Ukraine. We don't know what will happen with COVID. There are a lot of things, a lot of uncertainties. So it confounds attention and uncertainty. It also confounds attention with the ability to form an expectation. It's like the ability of the agent. So we basically want to have direct evidence of inattention that is confounded by these factors, which is uncertainty and kind of like the model that the agent has to form expectations. So this is what our first contribution is, to suggest two novel measures of attention or inattention of US consumers to inflation. And we believe that they are not confounded by uncertainty and forecasting ability. So what are these measures? So here is the main question of the Michigan Survey of Consumers, and we are using the Michigan Survey of Consumers that ask the following question. During the past 12 months, do you think that prices in general will go up, go down or stay the same. It's difficult for me to read, to stay where they are now. And there are different options that you could choose. And basically what we did is we stared at it. What can we say from this question? And after staying for a long time, we realized some people say stay the same. And then if they are responding this way, then there is a follow-up clarifying question asking, do you mean that prices will go up at the same rate as now, or that prices in general will not go up during the next 12 months? And so basically, people who say go up, they say basically that prices will continue to go up, but at the same rate as today. They basically say what we think inflation is going to be, it's going to be the same as the inflation is today. And then they are asked, like everybody else, so that's the following question. By about what percent do you expect prices to go up or down on the average during the next 12 months? And then they're asked to basically give an assessment. So our first measure is, so we are looking at this subset. This subset of respondents basically say, we believe inflation is going to be the same as today. And so when we ask them, so what is it? It's basically their assessment of inflation today, not forecasting. And that's the kind of like the innovation in those measures. So the first measure is to look at the percent of the subgroup that say don't know, because they tell us, oh, I think prices will go up at the same rate as today, so inflation will stay the same. And then we ask them, so what is it? They say, oh, I don't know. So what does it mean? It means that they didn't pay attention to current inflation. So we look at the percent of the don't know responses of this subgroup. So that's our first measure. The second measure is a complement to the first measure, and this is basically looking at the people of this and the subset that did give an assessment, how wrong they are compared to realized inflation. So that is our second measure. And we believe that this is not confounded by uncertainty because they are telling us that they think that inflation will stay the same. So they have all the information they need in order to give the assessment. Okay, so you may wonder, who are these people, right? Or maybe they're just confused. Maybe we don't need to really pay attention to them. Well, we looked at the demographic of this group, and we have age, household income, their gender, and their education. And what we find is that is important is that they tend to be better off financially compared to the rest of the sample. And they also tend to be more educated than the rest of the sample. Now, both income and education has been shown to be correlated with better financial understanding, better financial information, and more accurate expectations. So if anything, this group is a group that knows what better than the rest of the population what it's doing and kind of like about inflation. And indeed, when we look at their error in their expectations, then we see that they are similar to the rest of the sample in terms of that they also kind of like tend to overestimate the inflation. But when we look at the absolute error, we see that they're actually more accurate than the rest of the sample. So they are not crazy people that have no idea what they're doing. They're actually more accurate than the rest of the sample of consumers in the United States in the Michigan survey of consumers. So we are confident in looking at that group. So now here is an illustration of the first kind of like the hypothesis, kind of like translated into the first measure. We want to kind of like see if there is systematic relationship between that and inflation. So we imagine there is individuals differ by this cost-benefit ratio, and they are distributed according to this commutative distribution G. And so each individual chooses attention level, which is basically choosing the noisiness in the signal. And if you remember from before, the level of attention is related to this cost-benefit ratio. So we will have some threshold. The threshold will be such that if the cost-benefit is below a threshold, then you pay attention. If it's above this threshold, you don't pay attention, at least not to the point that you will be able to give an assessment. So that will be our don't know measure. So if we look at that on the graph, we imagine some kind of a threshold of this ratio threshold. The people that are up to that point will pay attention. the people who have cost-benefit ratio that is above the threshold will not pay attention, or at least not to the point that they are comfortable to give an assessment. That will be our don't know response. Now, if this cost-benefit ratio change with inflation, so it's going down with inflation, that it basically means that we will have a shift in the cumulative distribution to the left. And so what it means that we will expect the don't know share to go down. So that is what we expect to see if this is indeed what's going on. So this is the scatter plot of the first measure. It's we call it the don't know share in the U.S. Over on the x-axis we have the inflation in the U.S. and as you can see we find this negative relationship. Of course, we run also regression to control for the other kind of like unemployment, also volatility in inflation, and we find that there is a negative significant relationship between inflation and this first measure of inattention. That is, inattention declines or attention increases when inflation increases. Here we can also run individual level regression and control for demographics, and we do that too, and we find the same result, qualitative result, negative relationship between this response of don't know and level of inflation. We ran all sorts of robustness checks to take out recessions before 2008, to take out periods where errors were too high, inflation was too high, etc. These are all here, and we find consistently negative relationship between this measure of inattention and level of inflation. So this is our first measure. And then the second measure is the complement of this, and this is the error in the assessments. So basically, each individual is choosing the level of attention M, and the aggregate estimate can be written as follows. On the left-hand side, we have the estimation error. Here on the right-hand side, we have past forecast error multiplied by 1 minus this attention variable M, and then we have some common signal noise here, MT, ET. And basically, we can estimate this model, and we can look at the coefficient on the past forecasting error. And if this is indeed correct and attention goes higher when inflation goes higher, then we would expect the coefficient here on the past forecasting error to decline with inflation. So that is the first thing we do. We estimate this model, and we'll look at the interaction of this coefficient with inflation, and we expect that to be negative. The second stage of this estimation is to take the residual of this equation and take the absolute value, take the log. And when we do that, we basically should find that it will be equal to the log of this attention variable MT plus an error. And then we think that the level of attention is increasing with inflation, so we would expect this to have a positive coefficient on inflation. So if we run the log of the absolute value of the residual on inflation, we should get a positive relationship. So this is the second kind of like test of this measure 2. So here is the first step. So kind of like evaluating this model. So the model is here, just to remind you and me. So we have here on the left-hand side, we have the error in current assessment. So this is current assessment. It's not forecasting error. It's errors in current assessment over past forecasting error. And what we are looking at, we're looking whether this coefficient interacted with inflation, whether it's negative. And this is what we see here. And we see that indeed this is negative and generally significant. We ran, again, all those robustness checks as before. And you can see that throughout we get a negative relationship and almost always significant. So this kind of confirms the first stage of this assessment. The second stage is looking at the log of the absolute value of the residuals and see whether that is increasing with inflation. So this is the second step, and this is what you see here. Again, positive relationship as expected, and generally significant. Here it's not significant, but when we do all the robustness checks as before, we again find positive and significant almost always. So together, we take that to confirm also the second test of the second measure. So this is basically to say we introduce two new measures that we think are not confounded by other factors, and we find that it's as intuitively we believe it, but now we can show it in the data that it's increasing with the level of attention, so with the level of inflation. So attention is increasing with inflation. So one of the thing to maybe that came to your mind, oh, no wonder, because everybody is now writing about it in the news. It's probably because of that you find this positive relationship. So what we did is we constructed a news index of inflation following Carroll, and looking at the the New York Times and the Washington Post, looking at the share of articles with the root inflation out of the all the articles that are talking about inflation over the entire period of time. So this is kind of like a share. And we basically regress that on past inflation and the past index. Okay? And what we find is, as expected, that when inflation, the lagged inflation was higher, indeed this index is higher, as expected. The inflation is going up. We also have more news reporting about that. You may wonder, well, maybe there is more reporting and inflation is higher because of other economic conditions, so we kind of like use instrument variable for a surprise in inflation, and this is what you see here in the last column, and also there we find a positive and marginally significant relationship, but what's important is that it's the same magnitude as we got before. So that makes us believe that inflation indeed affects the level of reporting. So maybe that's the entire story. People just like, because it's in the newspapers, people see it, and then they know what inflation is, and that's why attention is increasing with inflation. So what we did next, we looked at the measure of don't know share, the first measure, and we look how that relates to this news index. And that's what we have here. And you see that the news index is the first line. Indeed, when it's higher, when we have more reporting of inflation, the level of don't know, so the level of inattention is declining. So in other words, more people pay attention. So that is what we would expect. What's important is that when we interact that with the level of inflation, we see that the effect of the news is even stronger on the share of don't know, meaning that not only that we have the supply of information about inflation, people are reading it more, perhaps paying attention more. It's kind of like this: we have the supply and the demand part that playing a role here. So together, I can now summarize. We have two novel measures of inattention to inflation that we believe kind of like improve on other measures that we have in the literature. What we find is that when inflation is high as it is currently, people pay more attention to inflation. And I didn't show it to you, but we also fit inflation forecasting model, and we see that that expectations are less anchored than when people don't pay attention, or kind of like when inflation is low. So when inflation is higher, they are less anchored, and that's very important for policy. And as a result, inflation may accelerate even faster when inflation is high. They might, and that might accelerate actual inflation. And so this is what we have for you today. Thank you.
Okay, thank you very much. I see some questions.
Hi, thanks a lot. Is this linear? So if it was not inflation high, but deflation, big deflation, would that mean that attention would be lower?
Well, according to the psychology part, the psychology would actually say that it is kind of like symmetric, not linear, but symmetric, because this is the sensation that we get from the changes in the price level. The rational inattention, then kind of like you need to think about what is the benefit of paying attention when inflation goes down. I believe that it will also mean that you want to pay attention because maybe then you want to decide you know, how much to weigh, maybe to wait in order to purchase whatever you want, like the car or whatever it is. So perhaps you can come up with a story that will say that you should pay attention also when you have a deflation, but it's less clear than the psychology story, actually.
Yeah. I have a question related to somehow the interpretation of your results. So, one reason why, so I would like to know whether it is possible, in your view, to distinguish between inattention from, in general, the precision of the signal we may have about inflation. So, I mean, we could receive more noisy signals about inflation even if we pay full attention.
Right.
And, you know, and it could be that, you know, I don't know if this is true or not, but when inflation is going up, perhaps also the precision of the signal that we receive changes for reasons that are orthogonal to the attention that we pay to prices.
So when you think about when you think about inflation that occurred, not forecast inflation, so you say that the signal. So the signal is, you can say, well, that's like the prices that we observe. If I pay attention to prices, I will get a better signal. So why would it be that in times of high inflation, if I paid the same level of attention, I will get different noisiness in the signal? So that's kind of like what the story.
I don't know, but I'm just making it up. If each of us don't observe all the prices.
Yeah, no. I understand. I'm just saying, if you have such a story, yes, then could be an alternative explanation to what we find. It's hard for me to come up with a story of why, if let's say my level of attention is like paying attention to the prices and reading the news, if this is the same, why would I get kind of like more noisy signal in times of high inflation, low inflation? So that, but if you can come up with a story, then yes.
And related, this is, I don't know if this is, in principle, some potentially testable implication is that if we look at the dispersion of inflation errors across different individuals, we should also see changes in this dispersion in the population.
No. So that's kind of like, there is no linear mapping between attention and dispersion. You can actually, we show it in the paper, it's non-linear, because what you get, even if you assume that everybody has the same cost-benefit ratio and the same level of attention, the dispersion would be basically a multiplication of the least level of attention and the error. Now, the both go in different directions. I mean, the attention M is basically you choose the noisiness, and that's the noise. So it's not kind of like a linear mapping. So it's not so clear to get this relationship.
Yes, it's a short question. So you had two nodes, right? Same and then don't know.
Right.
Could you just say something about the composition of people going down the same?
So the people who said same up, so those are the sample. This is what I showed you before. It's not just the same don't know. Those are the same up. That's the group that I was looking at. The demographics that I showed you, that's the same up.
And it doesn't change when inflation is high or low?
Oh, it's the composition is changing somewhat, not dramatically. But the way it changes, it's actually going against our hypothesis. If you think that the more educated individuals are better informed, it actually goes in opposite to our hypothesis. So kind of like makes our results stronger in a way. So basically, when inflation gets higher, less educated people get into this group compared to when inflation is low. And so if you think that they are less informed, the less educated people, then we should see more inattention when inflation is higher, while we see the opposite. So it actually goes against our hypothesis. But we did look at that.